The only thing stopping us from connecting with the billions of people across the world is language. So what if technology could eliminate that barrier instantly? Well, this has been my reality for years, and not with just random people all over the world, but actually with my own family. Imagine sitting across the table from your own grandparents, wanting to ask them about their life, hear their stories, but you can't, because you can't speak the same language. This is the reason why I'm building something completely new from scratch. So welcome to a brand new series where I'm going to be building a real-time translation application in public, and I'm going to bring you along with the journey. I'm going to document the entire thing, everything from ideation to the initial development, experimentation, the launch of this product, and then hopefully at the end, actually commercialization as well. So you'll see end to end how somebody goes from an idea into a product and all the nuts and bolts in between. So before we get into all of that, let me take you back a little bit. I grew up in London, a very diverse place, and I actually grew up as part of a mixed heritage family. Half my family is Indian, and whenever we'd go and visit them, I had no idea what was being said. And one of my biggest regrets as I've gotten older is not being able to communicate with some members of my family. People that have so much knowledge and wisdom. And it just seems silly that the only barrier to that was language. And as I've gotten older, I've realised how important it is for me to reconnect with that side of myself and to discover that part of my heritage. So what was stopping me? What's the problem? Well, our family is from Gujarati in India, and the language that my father's side speaks is not on apps like Duolingo. And yet, even though it's not accessible, I'm around people all the time that are constantly speaking this language. So I started asking myself, what if I could listen to these conversations in other languages that I don't understand, but I could get feedback on what they're actually saying in real time in a language that I do understand, in English? Even better, what if I could actually get responses in real time about what I should say back to these people, so that I can actually start to strike up and hold a conversation with them? Because there's nothing worse than this feeling of sitting in a room where they're all speaking a different language and you essentially just sink into your chair and are in your own world, because you literally have no idea what they're saying. So this idea hit me hard, and I knew straight away that I had to build something for it. And initially, of course, I'm building it for myself, but this isn't just for me. This is for the thousands of people across the world that want to connect with their culture, with their family, and with their roots, but haven't been able to because of language barriers. If you've ever felt like a stranger in a room where people are speaking another language, you'll know why this is so important. So let's do this. This is my starting point, essentially. The first thing I wanted to do was just to prototype something as quickly as possible, just to see whether I could actually use some open source technology to stream my voice into a microphone and then try and translate it into English in real time. So there's a few sort of like constraints here. The first is obviously using an open source model. Is there an open source model out there that can handle the Gujarati language? Number two, can I get a text model that can translate Gujarati into English? And number three, I need something where I can stream the audio from my microphone in real time to this application. So number one, the Gujarati speech to text model. As I said, I wanted to start with open source because that would allow me to prototype something really quickly. So what I did was I came to this website here, Vosk. Now Vosk has a whole bunch of open source speech to text models. They're really great for prototyping and in some sort of like more advanced use cases as well. But on this webpage here, it has a list of all of these different models that it supports. So it has English, obviously, it has Indian English as well, various other different languages. And what I was able to find was Gujarati. So there's two different models here. We've got a large model, which is about 700 meg, or a small model, which is about 100 meg. Yeah, that's right. So I actually downloaded both. You can download these literally just by clicking on this link. And I put them into this models folder here. So I've got these two models ready to go. Basically just to compare side by side which one works better. Obviously in a production environment, this needs to be as quick as possible. So ideally we'd want not only a model that's powerful, but also really fast as well. But whilst we're just testing locally, it doesn't really matter too much. And then thinking about the components that I needed. So I needed something that was going to stream my audio through the microphone and into this speech to text model. So what I did was I created this class here. So this Vosk service also has a Python API as well. So you can see that I'm importing it here. And I'm actually using this sound device Python package as well. So I put together a requirements file that includes all the different packages that I needed. You've got the sound device package, you've got Vosk, and a whole bunch of other stuff that I'll go through as well. So, as I said, it's really important that this is real-time. So I wanted to create a class that I can instantiate to handle the real-time streaming of audio to this application. Essentially, this is just all set up. The main method here is this stream method, which takes the raw input stream from the microphone. And you do have to specify which input mic you're going to use when you run the program as well. And then it basically just listens and waits for some input audio. Once it gets that input audio, it then runs that through the model, which is on this line here. So you can see that it loads it into JSON, but then it calls this recognizer method here, which in the init method is basically an instantiation of the Kaldi recognizer. So it's using the model and the sample rate to basically transform the incoming speech into text in the language that the model has obviously specified. And then it's basically just returning this information. So that's good. But then on the translation side, okay, so that's great that I can sort of like transcribe Gujarati, but I still have no idea, you know, what it all means. So I needed something to translate Gujarati into English. So if I come over to the translator file, and naturally because I was looking at open source, Hugging Face was the first place that I looked. And on Hugging Face, there is so many good models and so many good resources, it's ridiculous. I just can't believe that it's actually just, you know, such an incredible online community, to be honest. And on here, I was able to find this model here, Opus MT Inc to English. Essentially, this is a model that will transform Gujarati and other Indic languages into English. There was a couple of other ones that I found as well. So let me just have a look quickly. This one as well. So AI for Bharat, Indic Wave to Vec. So I also am going to test this as well. But essentially these models will give me the engine, if you like, to translate the Gujarati script into English, which is obviously what I need. So in this translator file, I'm importing the Hugging Face transformers package so that I can make use of these Hugging Face models. And these Hugging Face models, thankfully, are openly available as well. So yeah, it's literally just a case of telling the transformers package to look for this model, which is great. So yeah, I've created a class once again just to keep things nice and modular and to keep things concise. So this is the streaming translator. Similar to the streaming for the microphone, this is also going to translate using a stream as well. Once again, all of this is mainly just setup, and then there's a few sort of like helper methods as well. So this is actually going to be generating the translation, some helper methods for the actual translation itself, and then an update method as well, which is essentially just processing all of the sort of text that's coming in and just organizing it so that it can be printed to the terminal. So that's all good. I'm quite happy with those two classes. Now obviously I want to test it. So I've created this main file, and I'm actually using the rich package to print the output to the terminal in a much more interactive way, rather than just printing line by line. Then essentially I am instantiating the automatic speech recognition using the class that I created, so this Vosk Stream ASR class, instantiating the translator as well, and then I'm just using the live class, which comes from the rich package, to then essentially display the incoming text on the screen. So let's give this a go. And to start off with, I'm going to use the small Vosk Gujarati model, and I'm going to start with the Opus MT Inc model as well. So let's give this a go. Let's activate the virtual environment. And let's run this. In fact, what I need to do first is I need to check which output my microphone is. So in the README file, I added some commands that help me with this sort of stuff. So if I just do this, I've got a whole load of microphones attached here. So device number 1. Okay, sounds good. So now I can pass this into the main file. So if I do this, take a second. Before I go ahead with this, I obviously need to test this somehow, but I can't really speak Gujarati. I mean, there is one thing that I can say. It's very basic. I can basically say my name is Aaron. Maranam Arun Chair. So I'm basically just going to say that over and over again. I do have a video on YouTube that I can also kind of like play, which is like some random person preaching and educating in doing like a lecture in Gujarati. But let's test it on my own statement to start off with. Mare naam Arun છે. Mare naam Arun છે. Okay. I mean, it worked. It was able to transcribe the Gujarati. Obviously, I can't say for sure whether it was an accurate transcription of the Gujarati language. Yeah, the English was not great, I'm not going to lie. But it did give me some English, which I'm happy with, to be honest. Just the fact that this is actually the constituent parts are working. We've got Gujarati being transcribed in real time, and we've got English being rendered and translated in real time, even though the translation is clearly terrible. It was a little bit buggy when I ran the actual program as well, as you can sort of see by this output. But we've got all the raw materials here, which is kind of what I was looking for in, you know, the shortest time possible. So let's just let's try the other model. Let's go to this one. Mare naam Arun છે. Mare naam Arun છે. Okay, I mean, not the same error, but still not correct. It's actually giving me Gujarati transcription in the English section, which once again, I don't really care about for now. And by the way, if someone is Gujarati that's listening to this, I probably know that I'm butchering the pronunciation. Cut me some slack. But yeah, once again, it's working, but obviously things can be improved. To be honest, this is kind of what I expected when I wanted to use open source models to start this off. But this is exactly kind of what I wanted, just prototyping something really quickly. So even though this is not great in terms of the outputs, I'm actually happy with this. What I'm going to do is I'm going to go back to the original translator model, and I'm going to use the bigger Vosk model as well. Let's just clear this. Let's run it again. Mare naam Arun છે. Mare naam Arun છે. Okay, I mean, we're much closer. I'm actually really surprised. I mean, look, it got my name. Okay, there's clearly some duplication in here as well, in terms of, you know, the tokens being duplicated. But it's pretty close. My name is, and then it just hasn't understood my name at all. Once again, I'm probably butchering it in a Gujarati pronunciation, but still. I'm happy with this. This is actually really cool. So yeah, as I said, the whole purpose of this was to prototype something as quickly as possible. And in terms of the core functionality, the speech-to-text, the translation, and the rendering, all of this happening in real time as well, I'm really happy with this. This is awesome. This essentially gives me the validation that I need. Maybe in the long run, I would utilize other open source models and maybe even train my own open source language model, which would be a really cool kind of like stretch vision. But realistically, for this to be production ready, this isn't really going to cut it. So in the next phase is I'm going to look for other services that I can use and how I can start packaging this up into something that looks more like a product. Because at the moment, this is just a bunch of scripts. But yeah, this is the start of my real-time translation app. I hope you're enjoying this video and I hope you can join for the journey. Stay tuned because I'm going to keep building this every single week. And I'm going to show you absolutely everything as we go along and as we build this into a real life product that hopefully loads of you can use as well. So if you're enjoying this series and you're enjoying seeing me build something completely from scratch, then don't forget to like, subscribe and turn on the notifications as well so that you'll see when a new episode comes out. Let me know what you're building too. I'd love to hear some of the ideas that you want to execute on as well. But for now, I'll see you soon.